101 notes, surface area of prisms. Your practice is here, and I'll show this again at the end of the video. So the first thing we need to know is what's a polyhedra and what is a prism. A polyhedra is any solid or three-dimensional shape with flat faces. So it can't have any rounded edges, as you can see. Spheres don't count as polyhedra. Cylinders and cones do not count as polyhedra. We'll talk about those later. So what we have here are prisms. Prisms have two parallel and congruent faces, which we call their bases. Now, sometimes the base is the top and the bottom, and sometimes it doesn't sit on the base. So for this triangle, for example, this is a base and this is a base because they are congruent and parallel, but it's not sitting on the base. We still consider this to be the base. With the rectangular prism, this could be the base, this bottom, or the two sides could be the bases because they're all parallel and congruent. For the pentagonal prism, this pentagon is the base because it's congruent and parallel to this one. As you can see, all of the other faces are what shape? They are rectangles in all of the cases. So in this picture, you can see the bases. I'm coloring blue. Those are the bases because they're congruent and parallel. And then the lateral edges, I'll make them red instead. The lateral edges are parallel to each other. And the faces that connect the two bases are called a lateral face. So the lateral surface area is the sum of the lateral faces. And the total surface area is the sum of the lateral area and the base area. So sometimes we find with the bases and sometimes we find without the bases. So this sometimes we refer to as LA, lateral area. So for this example, what I'm going to do is I'm going to redraw this triangular prism as a net. So kind of what we're going to do is make a cut. Pretend like we're cutting it here, 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 and here, and then flattening it out. So what would that look like? I would have what's on the bottom of it right now. Think about what are the dimensions of this rectangle. This is 14 units, and this is 20. So this matches up with the 14 here, and a different color, with the 14 here, and the 20 across this way. So now attached to it, the face that's kind of facing you now over here, I'll put that one on the right side. How wide is that one? That one is 15, and it's also 20 units tall or long. And then what's currently the back, this guy, What are its dimensions? Also 20 and 13. So now we have the two triangles left over. So I have these two triangles. Are these right triangles? They're not right triangles. They have an altitude which makes two right triangles, but in and of themselves, they are not right triangles. So I'm going to attach these two triangles here and here because they have a base of 14 and a height or an altitude of 12. So I want you guys to think about how we can make this as simple as possible. I'm going to move that 14. And we want a process that we can repeat. Okay, I think I'm going again. I paused for a moment there. So we could look at this as 1, 2, 3, 4, 5 shapes, right? Find the area of each, add it all together. Or what we want to do is we want to come up with a formula that allows us to find the area of any figure that, any prism, right? That has two bases and a lateral area. So let's first look at these two triangles. So these two triangles that I have in black here, okay? I have two of them. So I have 2 times 1/2 times 12 times 14. I know I could have done 6 or 7. I'm leaving it in this way for a reason. Now I could think of this as 3 rectangles, or could we look at this as one big rectangle? So if I looked at this as one big rectangle, we would have a height of 20 and a base length of 42. So that gives us a total area. I have 168 here and 840 here. For a total of 1,008. So let's look at what we did here and see if we can come up with a formula that we can use for any prism. What did I do here? This is what? This is the area of my two, what are these called? This is the area of my two bases, and I will always have 2 of them because it's a prism. How about this 42? The 42 was this total length. Picture wrapping this back up. This length that I highlighted in green can also be, or is also, the perimeter of my base. So we represent that with a capital P. And then this 20 is the height of the prism. That's my total surface area. So B, capital B, stands for area of the base. Capital P stands for perimeter of base. And that works no matter what shape our base is. So our base could be a square, a triangle, a pentagon, a hexagon, a trapezoid, anything that we know how to find the area of, our base can be any of those shapes. And eventually it will be a circle. So on this page, we can organize all of our formulas here. So we have prisms. Let's talk about our surface area. That's what we did last. So we found 2 times capital B is base area. If you want to jot that down somewhere else on this page, it might be helpful because we're going to use that again. Plus capital P for perimeter of base times the height. So now which portion of this formula is our lateral area? Let's look back at our previous one. So our lateral area are these 3 rectangles, 1, 2, 3 rectangles. So our lateral area is that perimeter, that green line, times the height. So our lateral area is the perimeter of the base times the height. So again, capital B is base area. It is not a length. It is an area of your base. And then at the bottom here are your practice problems. Oops. And that's not due Monday, that was from, this is due whatever date tomorrow is based on when you're watching this video. Okay? As always, if you guys have questions, please let us know. Thank you for watching.